So combining functions here, or composition, I should say composition of functions. Let me rewrite that. So we're going to do composition. Whenever we talk about composition of functions, this is f composed. We're going to use an open circle with g at x. So what that means is that we're going to take whatever the g of x function is, and we are going to substitute it into the x for the f of x function. We almost go the backwards route. So we're going to take, so again, we're going to take g of x, and we're going to substitute it into f of x, okay? And then if we do the opposite, where we do g composed with f of x, so we go like this, then we're doing the opposite. We're going to take the f of x function, and we're going to stick it into the g of x. So this one, we're going to take f of x and substitute into g of x. Now, there are some official definitions, and you'll see this if you go through through Hawks, where it says that this guy right here equals f composed with g of x, or f at g of x, and this one is g at f of x, okay? So basically in math terminology, that's what it looks like. I personally think that using arrows and highlighters will really help you understand what's happening with these functions as far as substituting one into the other. So you're going to see me do that, where we do arrows and we highlight and we circle and we say, okay, we're going to take this guy and we're going to stick it in here. I just think it makes a lot more sense in our brain sometimes when we can see it visually like that instead of just the definition. All right, so we're going to do our first example here. So number one, we're going to compose f of x, which is going to be x plus 4, with g of x, which is going to be x cubed minus 2. So these are our two functions. We are going to do two steps. So the first step is going to be f composed with g of x. And they do like to put a parentheses around the f composed part and then the x. So although the parentheses around the f composed with g is not necessarily needed, it's just keeping them together. So again, remember what we talked about. That means that we're going to take the g of x function and we're going to substitute it into the f of x. So like I said, I'm going to do exactly that. I'm going to take the g of x function, so I'm going to put a box around the x cubed minus 2 because that's the function, and we are going to draw an arrow, and we are going to put it in to that x right there. So instead of having an x, we're going to put x cubed minus 2. So this is going to be x cubed minus 2 plus 4. Again, all we're doing is this right here is this function, and it replaced that x. Now, we do want to simplify because we can take the negative 2 and the positive 4 and combine those together and get x cubed plus 2. And this would be our answer. All right, so I'm going to rewrite the functions again. I always like to do this, especially if I'm doing this on paper. Just again, I like to draw my arrows and stuff and highlight. So I've got my f of x, which was x plus 4. Our g of x, which was x cubed minus 2. This time, for our second step, we're going to do g composed with f of x. Okay, so we're going to take the f of x function this time, and we're going to stick that into the g of x function. So f of x is x plus 4, so I'm going to put a box around that whole statement. I'm going to draw my arrow, and I'm going to put that into this x right here. Notice I'm only boxing the x, not the x cubed, because the cubed is part of my function. So I'm going to take that x, and instead I'm going to put x plus 4. So I am going to put the x plus 4 in parentheses because I do want to cube the entire statement. So we're going to have x plus 4 and then cubed minus 2. Now, you could go through the process of multiplying x plus 4 cubed. If you did that, you would have to do 3 parentheses and do x plus 4 times x plus 4 times x plus 4. You'd have to FOIL, and you'd have to FOIL again, and it's a big process. Or you can just leave it just like this and say, that's my answer. Okay, and again, all we're doing is taking this x plus 4, we're sticking in for that x. So we see that x plus 4 going in for just the x portion. All right, so let's try another one. So question number 2, our f of x is going to equal 1 over x. And our g of x is going to equal x minus 1. So for part A, again, we're going to do f composed with g of x. So again, I'm going to do my circles here on my boxes. So I'm going to take the g of x function. We're going to stick it into the f of x function. So my g of x is x minus 1. So I'm going to take that whole thing. I'm going to put it here in the denominator where my x is. So this is going to be 1 over x minus 1. And that's about all I can do right there. I'm done. That's my new function. That's my composition of functions. All right, so I'm going to rewrite it again. So we've got f of x is equal to 1 over x. G of x is equal to x minus 1. And for our second step, we're going to do the opposite. We're going to do g composed with f of x. And a lot of times you might hear people call this fog and goff. Obviously fog, because that's what it looks like you're putting with that open circle. So fog and goff is another way people kind of abbreviate this particular style or this composition of functions. So we're going to take this time the f of x function. We're going to substitute it into the g. So I'm going to put my box around the f of x function, which is 1 over x. I'm going to bring it over here. I'm going to replace that x with 1 over x. So this is going to be 1 over x minus 1, and this is my answer. If you just really felt the need to get a common denominator and bring that fraction and whole number together, by all means, please go ahead, but it's not really necessary that you do that. Okay. All right, so I do have one more example for you. And in this one, we're not only going to find the fog and goff, we are actually going to find the domain of the fog and the goff function. So f of x is going to equal x plus 3 over 3. And g of x is going to equal x squared minus 4. I completely lied to you. We are not going to find the domain and range on this one, and I have one more that I'm going to do with you that we will. So for right now, we're just going to find the fog and goff on this. So for A, we're going to start with the fog, or f composed with g at x. So again, that means that we're going to start with the g of x function. We're going to stick it into the f of x function. So remember that this is my g of x, x squared minus 4, and it's going to come over here. I'm going to replace that x with it. So this is going to equal x squared minus 4 plus 3 all over 3. Okay, again, remember I'm taking that x squared minus 4 and I'm just substituting it in for the x. So the x is gone, x squared minus 4 in its place. The one thing we are going to do here is we are going to combine that negative 4 and positive 3. Kind of the rule on combining stuff is in Hawks is if it's really easy to like say, oh, look, those are like terms, I'm going to add them together, you need to go ahead and do it. If it's a really complicated simplifying, like that one where we would have had to cube it, most of the time we can just go, we're going to hands off on this and it'll be fine. Okay, so this is going to end up being x squared minus 1 divided by 3, and we're done right there. All right, so I'm going to again rewrite my functions. I just like to do this because it makes it easier for me to do my boxes and highlighting and stuff like that. So g of x is equal to x squared minus 4. And this time we're going to do the opposite. So we're going to do the GOF, or g composed with f of x. Again, that means that we're going to take the f of x function. We're going to stick it into the g. So again, circling my f of x function this time, x plus 3 over 3. I'm going to bring it over here, and remember, we're just going to stick it in for the x. So the squared is going to stay that. Basically, that means that we're going to have that fraction, x plus 3 over 3, in a parentheses, and we're going to square it. So this is going to look, this is how it's going to look. X plus 3 over 3 in parentheses squared minus 4. Now this is the one problem I'm going to tell you, that we are going to do one thing to kind of help this out. We're going to take the squared and we're going to give it to the top and the bottom. So what we're going to do is we're going to keep the top in parentheses. We're not even going to multiply it out. You're just going to say x plus 3 squared over, but then you're also going to come down here and you're going to square this 3. So 3 squared is 9 minus 4, and then you're going to keep your answer like this. Again, if you really wanted to, you could FOIL the numerator, the x plus 3 times x plus 3, get a common denominator, subtract the 4, do all that kind of good stuff, but you can just leave it like this. Typically, Hawks won't like it in the first one. It'll tell you it's not simplified, but if you'll just take that squared and give it to both the top and the bottom, keeping that top in parentheses and then squaring that bottom number, you'll be fine, and you won't have to go through the rest of the process, and this would be your answer. Okay, so I got one more again. This one is going to be lots of fractions, and we are going to do the domain and range on it. So our f of x function is going to be 1 over x. Our g of x function is going to be x minus 2 divided by 2. So for our first one, again, we're going to do f composed with g of x, our fog, and then again, on top of that, after we figure that out, we're going to find out the domain. And we are going to have to do some simplification with this guy with the fractions. So we're going to take the g of x function, and we're going to substitute it in for f. So this is our g of x function, x minus 2 over 2, and we're going to plug that into that x right there. So this is going to be 1 over x minus 2 divided by 2. And again, this is one of those instances where we do actually need to simplify this guy down. So what we're going to do is a little bit of scratch work over here to the side. What I'm going to tell you is, instead of using this division here with the big fraction-y guy, what we're going to do is change that to a division symbol, and this is going to be 1 divided by x minus 2 over 2. I like to always put my fractions over 1, so this would be 1 divided by 1 times, remember, we keep the first one, we change to multiplication, and then we take this fraction, we flip him over, so he's 2 over x minus 2, and we multiply straight across, so we get 2 over x minus 2. So this would be our answer here, 2 over x minus 2. Okay, that is the easiest way to take that fraction and reduce him or simplify him down to a singular fraction instead of having 2 there. So now, when we find the domain of this guy, the only thing we have to worry about is that x minus 2 in the denominator, because it doesn't have a square root, but it does have a variable in their denominator. So we're going to say x minus 2 equal to 0. Adding that 2 to both sides. So x is equal to 2. And again, remember what this means is you have a number line, and here at the number 2, you have this giant hole. It can be anything to the right of 2, it can be anything to the left of 2, it just can't be the number 2. So we're going to use a union. We're going to go from negative infinity to 2, and then we're going to go to 2 to positive infinity. Everything's going to be parentheses, and there's our domain for that really weird function. So I know I went through that pretty quick, and I know sometimes some of you might be going, what's going on over here? If you have a question or concern about what we did over here, let me know. Remember, the big thing here to remember is to keep, change, and then flip. That's our rule for division. Keep my first fraction, change to multiplication, flip my second fraction, and then right here, remember, we always multiply straight across. Okay, whenever we're multiplying fractions, we just multiply straight across in this instance because your first fraction was just 1 over 1, made the multiplication very easy. All right, let's do step 2. So again, I'm going to rewrite my functions. F of x was again 1 over x. G of x is x minus 2 over 2. We're going to do this time the golf, G composed with f of x. So this is our part 2 or part B. So this time we're going to take the f of x function, we're going to put it into the G. So again, I'm going to circle or box 1 over x. That's my f of x function. I'm going to bring it over here. I'm going to put it in for that x right there. Sorry, I didn't make my line long enough. So we're going to do 1 over x minus 2 over 2. And you think, well, I'm done. Again, unfortunately, we do need to do some cleaning up of this guy. So the first thing we're going to do is we're going to get a common denominator. We're going to ignore that 2 on the bottom. We're just going to work at the top here with the 1 over x minus 2 over 1. Common denominator is going to be x, so we're going to multiply this guy top and bottom by x. So this will be 1 over x minus 2x over x. Again, all divided by 2. Combine that top, so this is 1 over x. Oops, that is wrong. Let me try that again. How about 1 minus 2x over x over 2? So we're going to do exactly what we did on the previous problem. This time this is my division line. Okay, so I'm going to take the top, 1 minus 2x over x divided by 2 over 1. Okay, and we're going to keep, change, flip. So 1 minus 2x over x, change to multiplication, flip this guy, and then again we're going to multiply straight across here. So this is going to equal 1 minus 2x over 2x, and this is going to be my answer right there. Okay, and then for the domain on this guy, again, we don't need to worry about a square root, but we do have that 2x in the bottom. So we're going to take 2x equal to 0. We're going to divide both sides by 2 and find out that x can't be 0. So again, thinking of my number line, here's my 0. I have a hole at 0, but I can be anything to the right. I can be anything to the left. I just can't be 0. So it's going to be our union here in the center. We're going to go from negative infinity to 0. And then on the right, we're going to go from 0 to infinity. Now you'll notice that both of the functions have these weird domains with the holes in them, so you have that union. But notice on the second one, or the golf, my hole was at 0, whereas on the first one, my hole was at 2, and that has to do with the way that we're doing the composition and who's going in for which function. So kind of have to be really careful with that. If you have any questions about this or this type of problem, or if you need any more examples of the composition of functions, just email me and let me know.